Welcome to SMART Notebook Math Tools. In this session, we'll be looking at how to use the equation editor and also the handwriting recognition tool. First, using the equation editor to insert equations. Select the keyboard and then select the equations icon on the secondary toolbar or the math toolbar. Click on the workspace and begin to type an equation or formula such as the area of a circle, a equals 2 pi r squared, going back and forth between the equation editor and your keyboard. Once completed, use the selection tool, and then you can move your equation anywhere in the workspace. You can also import equations from a Word document and use the equation editor to edit the equations. Here's an example where we can insert and edit using the equation editor. So to solve for the following equation, select the equation editor icon, click on the workspace, and under the algebra tab, select the quadratic formula expression, and then use the selection tool to move that expression in the workspace. Now select the keyboard, and then with the selections tool, select it, double click on the quadratic formula expression, and then you can type in x equals quadratic formula expression so that you can solve for the roots. Now we can begin to substitute for the values using the equation editor. So here we might need brackets to substitute in the value -7 for b. Again, selecting for brackets and then -7, and then might have to open up the expression so that we can substitute for a and for c. Again, using brackets to substitute in -6, and finally for our last value, a, requires a bit of practice, and substitute in 3 for a. So here we have our quadratic formula now with values substituted, so students can see how to solve for the roots. Next, we can simplify expressions such as the fractional expression 1/2 + 3/4. And if I select that expression and use the arrow pull-down menu, you will see now I have a menu for math actions. If I select math actions, it will give me the choice of simplifying numerically or symbolically, and doesn't give me any other choices since we would not be able to do anything else with that expression. For example, if I had to evaluate the following expressions, I would select the expression, use my math actions, and simplify symbolically so that I can see the steps. If I select the math actions to simplify numerically, I will be given an answer in decimal as a decimal number. Similarly, for the other expression, using my math actions, I can simplify symbolically. And then I can group all of those together and move it on my workspace. And then if I simplify in my math actions, choose simplify numerically, I get the answer as a decimal number. In my next example, I can solve the following linear system. The students would solve this graphically, and reading from the graph, they may select the point 20 and 700. And then they may want to check their answer, and so they can select the systems of equations, use the math actions, and this time they would simplify numerically. And then check their answer to see if they made the right choice on their graph. So there we have it as 20 and 700. Here we can start to find zeros. So again, the students may calculate and then check their answer. So selecting math actions. This time we're given many choices. In this case, we're looking for zeros. So finding zeros, and it selects, it works out to the one solution. In the other example, when we choose our math actions and simplify or find the zeros, we now have two solutions, x equals 2 and x equals -3. Might take a little while to solve. There we have, find the zeros, x equals -3 and x equals 2. We can also use this engine to look for maximum and minimum values. Again, the students can see from the graph and select a minimum value at 2. So they can check the results, selecting the equation, use the arrow pull-down menu, select math actions, and in this case, they're looking to find the extrema. And as a result, we will not have a maximum value. So no maximum value, only a minimum value of 2 at x equals 3. We could reverse the operations and solve for zeros and extrema and then use to sketch the parabola. So the students could calculate and then check their solutions using their math actions. We would find our zeros. At x equals to 4 and x equals to -2. And then select the equation again using math actions, find our extrema. Again, is looking for the equation. We can see that we have no maximum, only a minimum value at 1 at -9. And then the students can use this information to draw or sketch their parabola. Next, we'll look at the handwriting recognition tool. Here you see a number of one expression, a couple of equations. And so selecting for the fractional expression, seeing if the handwriting recognition tool, you can see recognize math ink. So if I select that, now I have it's recognized and I can select to accept it or decline it. And there you see that expression. With the area of a circle, you can see the symbol for multiplication. We would have to use that just as you're in your computer keyboard, the symbol for multiplication as a star. And so we need to write it that way for it to be recognized. So if I select that and then recognize Math Inc., we will see that the engine does accept it as a equals pi r squared. And lastly, if I select my trig equation, you can see that it's only grouped some of the terms and not all of them, leaving out the pi over 2. So if I now select the arrow pull down menu and ask it to recognize Math Inc., it will give me a response. Smart Notebook is unable to recognize the ink as a math expression. However, the tool is very powerful in that if I now group both of these and select recognize math ink, it does recognize this as one equation. Here's an example how this might be used. There are some do's and don'ts. First example, can you verify the maximum minimum value by simply looking at the equation? Now this is a little bit maybe confusing for students when they see it in writing, but as I start to use the tool to recognize the expression or the equation for both of these, it might make it easier for the students to recognize the values required to answer this question. And so now they can see when they're looking for the extreme values, they've got a +3 and a -3 quite readily read. So one of the do's is that it is useful to facilitate learning. And in that case, you would want to use the handwriting recognition tool. In the other example, the learning has already occurred. Expand the following, it's been expanded. We could use the handwriting recognition tool to make it more aesthetically pleasing. And so if I select all of those and ask it to recognize math ink, it will recognize the equation. It looks very pretty, but is there any editing? And in this case, maybe we don't use it just to make things prettier. Okay, so it has a value as far as learning goes, and possibly a value as far as aesthetics goes. So the decision has to be made whether it is useful for learning or not. In the next session, we will start to look at how to use the graphing tools and the table tools.